Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin. Wassalatu wassalamu ala ashrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Rabbi shrah li sadri wa yassir li amri wa hlul 'uqdatam min lisani yafqahu qawli. Allahumma la sahla illa ma ja'altahu sahla wa anta taj'alul hazna idza syi'ta sahla. Assalamualaikum and a good day to all of you. I hope you enjoy your holiday, Chinese New Year. Happy Chinese New Year to those who are celebrating CNY, and to those not celebrating, you are also need to celebrate because you are Malaysia. Okay, so for today we are going to learn about the kinetics, which is our last lecture for the course of SEBB1313 Statics and Dynamics. So as I said last week, we are going to have a pre-recorded video. This is the pre-recorded video. No, I believe that there is no question from you later on in this video. But if you have any question regarding this lecture, then you can text me or you can directly meet me either in my office or in my lab. Okay, so we move to the lecture, and then this is the kinematics. Okay, what you will learn for today is the first one is kinematics of particles. It is only particles, and also there are some other rigid body. Okay, which is we will learn to cover a rigid body as well. Okay, and then number two is we do have to recap again the free body diagram, which is you have learned it before in the statics. Okay, and then we will go through the example exercise. Okay, so before we go further about the lecture, so let me explain about the difference between the kinematics and kinetics again. So I believe that you have already know what is the differences between the kinematics, okay, and kinetics. Okay, so kinematics you have learned the previous weeks, and for today you will learn about the kinetics. So kinematics is where the rigid body or the particle is moving without any forces applied. Okay, so it's moving rigid body, okay, bodies, okay, particles, and then no forces. Okay, this is the kinematics. But kinetics, okay, so you will learn the same one, moving rigid body, okay, for particles, but there is some forces applied. Okay, so this is the difference between the kinematic, and of course in this type of kinematic you learn about the rectilinear, okay, and curvilinear motion. Okay, and then this kinematic you will learn about the rectilinear and also involvement of MA, which is the mass, and also acceleration. Okay, acceleration. So in this case, F equal to MA is 0. Okay, in this case, F equal to MA. So we will consider the MA. Okay, where the acceleration is there and the mass is also there. Okay, so we consider M and A. Right, these are the differences between the kinematics and kinetics. So I move to the next slide, which is a particle. Okay, it's not a particle, it's actually it is a rigid body as well. Okay, and then this is the scope that we cover in our syllabus. It is not similar like the mechanical student learn in their other graduate studies. In our biomedical engineering study, we only cover several topics, several syllabus, not all. So what we cover is the force and acceleration only, which is the number one here. So work and energy, we are not covering it. Impulse and momentum it is not also covered. Okay, so we only have one, which is force and acceleration. So for the force acceleration, you still remember this one? I believe that you are still remember this equation, which is this one, is the second Newton's law. Okay, So in a static, we consider acceleration is always equal to 0, so we become 0 always, and this one is static. Okay, in dynamic, okay, there are some movement which is we have to consider second Newton's law. So if you translate F should be equal to static that you learned before, okay, which is a free body diagram, and the MA is the kinetic diagram, which is involving the forces and also the acceleration and also the movement. Okay, kinetic diagram. Okay, later on you will understand about this equation or the similarity of the equation. And again, this is the same slide that I teach you in the static, where you have to draw FBD, free body diagram, and what you have to do once you have the figure from the question or from any problems, you have to draw the FBD first. And the first step that you have to do is the identification of all relevant forces. So you have to identify all relevant forces by drawing the FBD of the particle, okay, or rigid body, okay, or rigid body. Okay, and the procedure, I believe that you already aware about this one. So you have to draw the chosen section and they just separate from all other particles. So you have to choose, okay, and you have to detach or separate from all other particles. Okay, so I will go. Let's say you have this building, for example, okay, and then you have this system, for example, a box, and this one is pulley, okay, holding together, and there is another box here, for example, and then you have to let's say we have a and B here, okay. So based on this procedure, you have to draw the boundary of the chosen one, number one. So you have to draw the chosen. Let's say you choose boundary B, which is the block B. Okay, so you have to draw B only. Okay, all right, and detach from other particles. So this one is the problems. Okay, this is the FBD. Okay, so number two, import all external forces acting on the particles or rigid body. So this is number two. So the external forces is coming from the tension. I change the color. Okay, tension. For example, I put T. So this is the external forces. Okay, external forces. For a particle with a mass, put the weight mg acting at the center of gravity of the particle in the vertically downwards direction. So let's say this having mass equal to 100 kg, for example. So you have to put the mass vertically downward like this one, So it should be this one, okay. Alright, so this is number 3. So number 4, let's say the particle or the rigid body touching a surface, there is a normal force acting perpendicular to the surface and directing to the particle. So in this case, for the particle B, there is no touching surface. Okay, the touching surface is only happen at the particle A or rigid body A. Okay, in this case. So let's say you are drawing a BD for A, for A, and then you have this one lah. So let's say MA is equal to 50 kilogram. So you have to put this weight, okay, and then let's say there is some forces, friction, okay, that opposed to the movement. Then you have to put the forces, the friction there, okay. And of course, number 4 again here, normal forces acting perpendicular to the surface. Okay, so normal force should be like this one. Okay, let's say I put here, this one is normal force. Okay, so normal force acting perpendicular to the surface and directing towards the particle. So for problem for number 5, okay, which is the problems involving friction, so you have to put friction or friction force tangent to the surface of the contact against the direction of motion. So why I put this direction? Because it's again the direction, or movement of the particle. Okay, so you have to put this one, mu n. Okay, so this one is mu, so you have to put mu, which is already maybe some cases the mu is given normally. Okay, touching surface between two particles or rigid body. Okay, all right, so this is the FBD for B and also A. Okay, this is the way that you have to draw the FBD. Once you draw the FBD, then you can solve the problem, okay, by having this one. Of course, if you have this one, you can get T from Y analysis here. Okay, and then you will get T is same like this one or this one. Okay, and then you will get the answer for the, let's say you want to find the friction force here. Okay, and given mu 0.2 for example, you will get N straightforward. Or maybe you want to find a mu, okay, when you have the Newton, where you have the perpendicular forces is equal to this one. Okay, all right, so we move to the example 1. So before that, make sure that you understand the question carefully. Okay, unless you are already expert about it, you are not need to read the question. But again, the best option is to read carefully, and also the understanding on the diagram, also the sentences, also the given information there. So from here you have to put the inputs, or you have to list down all the given information. Okay, so example 1, you have to determine the required horizontal force P to initiate the 10 kilogram mass to move up the 30 degrees incline with an acceleration of 2 millimeter per second square. Okay, so the question asking you to find P. What is the value P when you have the box with this mass to move up with the inclination of 30 degrees Celsius, 30 degrees, okay, and then with an acceleration of 2 millimeter per second square. So in this case, when you have this problem, make sure that you put in your mind this one is no longer static, this one is dynamic. Okay, because we involving with the acceleration or the movement. Okay, so this one, the first Newton's law, is no longer applicable for this system, not applicable. So we have to apply the second Newton's law, okay, which is second Newton's law. So you have to apply F equal to ma. Okay, F equal to ma. And this solution, and this example, we do have two different solution. Okay, where it is depend on your definition of the axis. Okay, so you have to put in your mind again, when you want to solve the static and dynamic, there are many assumptions that you have to set early on. The assumption is depend on you. Let's say you want to assume this exists, for example. This is your assumption, your definition. Okay, let's say you want to assume the axis is following the surface like this one, for example, or maybe the other thing like this one. It's up to you. It's up to you. Okay, this one is depending on you. So but by practice, I normally suggest to have this option, okay, where you have this one, okay, the easiest one, which is vertical and also horizontal axis, Okay, and the other two, the other one is where you can use the same surface level, okay, like this one. So we will go through later one by one, okay, to ensure that you understand with the definition, okay, that you set earlier on. Okay, so let's say you have this one. So I draw again here, and it is the box is having 10 kilogram. Okay, and then move acceleration is 2 meter per second square. Okay, and then the mu is 0.2. Okay, this is the thing that you have to redraw again. Okay, so let's say let's say you put this definition ys, and then and the first of all you have to draw the FBD first lah. Okay, you have to draw FBD. So the FBD is like that one. Okay, so put everything there. Let's say you want to draw only the box, it's up to you. It's also acceptable. Okay, and then you put the forces P here. Okay, you put the friction coefficient or friction force which is acting this direction, F equal to mu n. So you have the normal here. Okay, and then you have the mass or the weight pointing like this one, W should be W. Okay, so this is your FPD. Okay, so if you can look at this one, okay, it is same like me but different direction. Okay, this one the lecture put it downward. Okay, it is same actually, it's up to you. Okay, and this one the lecture putting the from upward to downward, from top to bottom. Okay, and then it's up to you what type of difference, what type of the movement or direction from where to where. It's up to you. In the end of the day, you will get the same answer if you follow the first definition that you set earlier on. Okay, so once you have this FBD, okay, you can calculate, okay, to get the P value. So you can input all the information there. Okay, you can put the information there, right? What is the other factor? Okay, refer back to the original question. So you have to consider this one, F equal to MA. Okay, so F is the equilibrium system or the resultant forces for X and Y and X. Okay, MA will be consistent, and also it should be follow X and Y as well. Okay, so let's say you want to solve the first one, which is the X analysis. Okay, let's say this one is the definition of like this way. So I will show the definition like this way first. Okay, this one. Okay, let's say you define this one first, then you have to resolve into several components. So this one you have to resolve, for example, okay, this one it should be okay, F cos 30, okay, this direction, and this one should be F sin 30. Okay, F cos 30, F sin 30. So this one is the cos 30, F cos 30. Okay, for the X component. And then for this one, I choose another color, maybe what color that we have more. Wow, very limited color. Okay, so this one should be N. So let's say I put it here. This one should be 30. This one should be N cos 30. and this one should be n sine 30. So if you look at the free body diagram, you can have the X analysis. Okay, it's depend on you. It depends on you what kind of analysis that you want to start first. Okay, if you found that X analysis is the easiest one, then you can start with the X analysis. Okay, and then you have to consider this one. Okay, X analysis, this one. Okay, and then this one. Okay, all right. So but then you have two unknown. Okay, but if you this one is the way that you can observe the question and also the information given. Okay, let's say you want to find, or you want to solve Y analysis first. So let's say you want to solve Y analysis first. Okay, you only have one unknown. Okay, this one is the first one for the Y component, and this one is the second one for the Y component, and this one is also the third one. Okay, so from here we can understand that we do have a two unknown as well. Okay, two unknowns. So once you have two unknowns, then again you have to develop two equation. This is the thing that you have to remember. So two equation coming from two different analysis lah, like this one. Okay, alright. So again, if you have information about the things from the question, you can solve it. Okay, so this is the X analysis and Y analysis for F. So for MA, okay, again MA you have this figure. Okay, this figure, the movement, where is also you have to resolve into two components, which is maybe we put MA X. Okay, this one is MA Y. Okay, alright, so you have to resolve it as similar as the left part. Okay, again I want to remind again, so this should be coming from the forces only. Okay, oops, and this should be coming from the, this one is forces, so it should be coming from the forces, and so this one should be movement lah. Okay, alright, so once you have the information there, you can put all the information. This one should be 30 degree as well, should be if you have Y analysis or Y component, this one should be 20 Newton cos 30. Okay, for the X, for Y sine 30. Okay, this one should be Y. Okay, and then this is the thing that's similar to my diagram lah. So we do have the weight here. So we have the force, friction force, friction force, and this one is normal force. So once you calculated all everything, you will get one single unknown, which is normal force in the end of the day. So this one, for this one, because we have here, okay, which is 0.2, so you can input 0.2 in the equation, and you will get the final solution of the normal force. So in this direction. Okay, so then you have to solve for the X analysis. So the X analysis involve P, okay, normal forces. This one is the friction force, and this one is the MAX. Okay, it's coming from here, and you simplify it where you can put N inside this one. Okay, and then you will get P straightforward. Okay, so this is the way that you can do. Alright, So I hope you understand from this video, because it is not easy to explain using the video. So normally I'm not satisfied if I give a lecture in video, in the record video, because I cannot make you more understand about the topic. So normally I prefer to have physical, but then due to the holiday, so we cannot do the physical lecture. Okay, it's not easy to explain, and it's not easy to understand. I believe that you are difficult to understand if you only look at the recorded video. So if you have any problem regarding this, then you can meet me. Okay, so this one, if we use this assumption, so as I mentioned here, so this one is done. As I mentioned here, we have two different one. Okay, the orientation itself, which is horizontal and vertical, and number two is we are following the problem, or we are following the level of the inclination, like this one. Okay, so number two, this one. Okay, and then the FBD should be same, but the orientation is different. I mean, the axis is different. Okay, the MBD is same actually, but the axis is different. So it has again, it's up to you. You want to choose which one. The final answer will be similar. Okay, so let's say you are choosing this way. Okay, so let me erase the one. Okay, if you follow this direction, you have to resolve the same thing. You have to resolve some forces as well, like this one. Okay, it should be 10 times 9.81 sine 30. Okay, and this one, this direction should be, supposedly should be this direction. Okay, and then this direction should be 10 981 cos 30. Okay, and then this is okay, and this is okay following the assumption here. And then this one you should resolve into two component, which is p cos 30, and going down which will be sine 30. Okay, so this one x, this one is y. So you have to select the x1 first. Okay, let's say you want to solve the x1. This one is x1. Okay, this one is x1. Okay, and it should be another one, which is this one. Okay, so the green color is x component. Okay, for the orange color is for the y. So y. Okay, this is the left part. Okay, left part. So right part, okay, which is f equal to ma. So left is f, ma is right. Okay, so you have to look at this rigid body or movement. Okay, and then at this part, you only have one component, which is x component. Okay, which is x component only. This one is x component only. So y component is equal to 0. Okay, and then you have to substitute all the information in the equation. Okay, so you have the p cos 30, and should be minus because this direction. Okay, you have this one, and also this direction is also opposite with the assumption. Okay, it should be this one, and this one is this direction. Okay, and then for y, this one p sine 30, okay, should be negative. Okay, and then this one should be negative as well, is pointing downward, and also neutral is pointing upward, or not neutral, normal. Okay, in the end of the day, you will have two equation. So because you have two different unknown p and n, so you solve two equation there, okay, by having a multiplication or divide, division, okay, and then you will get the p in the end of the day. Okay, so the answer will be similar like this one, but different calculation or different axis. Okay, and why we show these two solutions, to make sure that you understand that you are able to determine any assumption or any axis that you like, depending on you, depending on the understanding. So if you are not you have not interested to have this assumption, then you can put like this way, for example, or maybe number 4 become like this one. It's up to you. But again, normally I ask my student to follow this one lah, to make sure that we are doing less mistake. Okay, so I think that's all for example 1. I will continue to the next video with the example 2. Okay, see you.